friends, the topic of our today's discussion is three-level laser system. Till now we have seen that the requirements for amplification of light are the incident energy density should be high, longer lifetime at excited state and population inversion. So these are the three conditions need to be satisfied to get light amplification. And we have already seen that to increase the energy density of incident radiation or the intensity of the incident radiation, we are using resonant cavity or optical cavity. Further, we have also seen that there are different pumping mechanisms are there to pump the atoms from lower energy level to higher energy level to achieve population inversion. But when longer lifetime at excited state comes into picture, we need to have some metastable state that we have already discussed in the previous video, right? So what is that metastable state? And metastable state is a state where the lifetime of the atoms is much larger as compared to the other excited state. In case of three-level laser system, we have seen that there is only one metastable state lying between the ground state and pump state. Further, in case of four-level laser system, there are two metastable states between the ground state and pump state. Today we will be discussing three-level laser system. Now from the name itself it is clear that in case of a three-level laser system there are three energy levels. One is ground state, let that energy is E1. Then the second one is metastable state and the energy of the metastable state is E2. The third one is pump state with energy E3. So these are the three energy levels in case of a three-level laser system. Further, we have seen that in case of two-level system, it is very difficult to achieve population inversion and hence lasing is not possible in case of two-level systems, right? Now we will see whether it is possible to attain population inversion and the lasing action in case of a three-level system. We all know that the atoms always they will be generally in the ground state. So E1 is the ground state and these are the atoms at the ground state. So if we are applying some radiations to pump the atoms to the higher energy state, then these atoms they will move to higher energy state and the state to which these atoms will move after observing the radiation, that state is known as pump state. So if we are incidenting some radiation whose energy is equals to E3 minus E1, then these atoms they will be pumped or they will transit from energy level E1 to E3. So if I am incidenting some radiation and this atom absorbs this radiation, that will move to energy level E3 and the energy of this incident photon is equals to E3 minus E1. Once this atom moved to energy level E3, it has two options. One is that it can come down directly to E1 through spontaneous emission or it may move to energy level E2. At this point, I would like to mention that the transition from E3 to E2 is non-radiative in nature. Non-radiative means when the atom is moving from energy level E3 to E2, it will not radiate any energy. I have already discussed about radiative and non-radiative transitions under semiconductor physics. I shall provide the link in the description box. If you want the details about radiative and non-radiative transitions, you can watch that video. So when we are providing some energy many of these atoms, they will pumped to energy state E3. Now they have two options, either they may come down to E1 or they may move to E2. So this atom, let that move to E2. As this transition is non-radiative in nature, there is no radiation coming out when the atom is moving from E3 to E2. Now let us see, this second atom is moving to E3 and it also moves to E2, and this is again non-radiative in nature, so there is no radiation coming out. Further, this one is moving to E3 and it is coming to E1, and this is through spontaneous emission. Now some atoms, they will move to E2, some will come down to E1. So these are the two alternatives available for these atoms. Okay. So during this process, what happens? We are providing energy. Atoms are moving to energy state E3. They will either come down to E1 or they will move to E2. Now the lifetime comes into picture. The lifetime of atoms at energy level E3 is tau 3, which is of the order of nanoseconds to picoseconds. Okay, so 10 to the power minus 9 second to 10 to the power minus 12 seconds. So of that order it will come tau 3. This is the lifetime of the atoms at energy level E3. But the lifetime of the atoms at energy level E2 is very high as compared to this value. So let the lifetime at energy level E2 is tau 2. Then tau 2 is much greater than tau 3. So the time for which the atom stays at E3 is much less than the time for which the atom stays at E2. So when these atoms are pumped to energy state E3 and they are coming to E2, they will stay here for a longer time. Okay. So by that time, many of these atoms, they will move here and many will come here, they will stay here. Thus a time will come when we will get more number of atoms at energy state E2 as compared to the number of atoms at energy state E1. Let the atoms at energy state is N2 and the atoms at energy state E1 is N1. When quite a good number of atoms are accumulated here, then we will get N2 is greater than N1. And if N2 is greater than N1, that means the number of atoms at a higher energy state is more than the number of atoms at a lower energy state. And this is nothing but population inversion. So we are getting population inversion, right? So we have seen that the transition between E3 and E2 is non-radiative in nature. Whatever the transition occurring from E3 to E2, that is non-radiative in nature. That means we are not getting any radiation during this transition. Now we have achieved population inversion as well. Now when the atom, they will stay here up to a time tau 2, after that they will automatically come down to E1 by spontaneous emission, right? Here it is non-radiative, but the transition which occurs between energy state E2 and E1, that is radiative in nature. So the transition between E2 and E1 is radiative in nature. So when a single atom is coming down, it is radiative, right? That means it will emit some photon whose energy is equals to E2 minus E1. So when this atom is coming here and it is emitting some photon, this photon will trigger stimulated emission by stimulating the atoms which are sitting at energy level E2. So this atom, this photon, if it will hit some atom, it will again come down and it will also emit one photon. So we are getting two photon now. These two photons, they will stimulate two more atoms, we will be getting four photons, and continuously that will get multiplied. So this is the radiation which is coming as our output. Okay. Thus, whatever the output we are getting from a laser, that is due to this transition. Okay, not due to this transition, because only in case of radiative transition we will be getting light radiations. That means we are getting the laser output whenever the atoms is moving from energy state E2 to energy state E1. So these are the two energy levels which are giving us the output, and hence this E2 is known as upper lasing level and E1 is known as lower lasing level. Thus, we have seen that in case of three-level laser system, we can obtain population inversion and hence we can get lasing action, right? Here this metastable state is acting as upper lasing level and the ground state is the lower lasing level. Let us look into the output of this three-level laser system. I am taking here the time axis and here this intensity. Okay, this is time. So initially what we have seen that this was empty, all the atoms were here, that means N2 was less than N1. Okay, N2 is the number of atoms at E2. I am considering these two because these are the two energy states because of which the lasing action is taking place. This is the radiative transition, right? So if initially what we have seen that this was empty, right? So N2 was less than N1. So no population inversion. If no population inversion, output is 0. So initially the output was 0. Okay. But after some time when the atoms they moved from E1 to E3 and they came down to E2 and start accumulated over here, after some time population inversion takes place, right? So once the population inversion took place and the stimulated emission starts, then we will get the output. Let the output is of some value I naught. The output will come here, but when these atoms they will move down to E1, after some time we will see that the number of atoms at E1 is more than the number of atoms at E2. That means again we are getting N2 is less than N1. Okay. If this is the situation, again population inversion will not be there. If it is not there, we are not getting any output. So this output will again come down to 0. Then again these atoms then need to be pumped to energy state E3 and from there it will come to E2 and it will take some time to establish the population inversion once again. Okay. So once that population inversion is re-established, again we will be getting the output. Okay. And further, when these atoms are coming down to E1 and we are losing that population inversion, for again the output will be 0. So that will continue. That means we are getting the output for a particular time, again it is becoming 0 and further it is increasing to the output. That means we are getting the output in pulsed manner, right? We are not getting the output continuously. Thus, in case of a three-level laser system, pulsed output is obtained. So we have seen that in case of three-level laser system, it is possible to obtain population inversion and hence we are getting some laser output, but that is in the form of pulse. It is not continuous. So can we get this continuous output in case of four-level laser system? Please think over this. We will be discussing about this in the next video. Thank you all. If you like the content of the video, please press the like button and share the link with your friends. Further, do subscribe to my channel to get the notifications whenever I am uploading a new video. Thank you all.